Hi grade 12s, my name is Katlego Nakedi and welcome to the KNUX lessons. Today I'm excited to be sharing this video with you and I hope you're going to benefit a lot from this video. In this lesson we'll be looking at a very exciting and interesting topic called differential calculus. Now this topic is the one that you're going to come across in your paper 1 examination. And it's very important that you understand this topic because it carries a lot of marks in your examination. So I believe that me and you, we're going to have an exciting journey going forward. And while we are still on that, make sure that you subscribe to my YouTube channel and don't miss out to any of the videos that I'll be posting in the next coming weeks. So without wasting time, let's look at what this differential calculus is all about. But before that, we need to see what the learning outcomes are for this topic. So basically, this is what you need to know when you say you've completed this chapter. Okay? So let me get my pen. So by the end of this chapter, you must be able to determine the average gradient. That's the first one. You must differentiate from first principles. You must differentiate using rules. You must determine the equation of tangent. You must use the remainder and factor theorem to find factors of each equation in the third degree. You must solve the equation in the third degree. You must draw a sketch graph of a cubic function using the x and y intercepts, turning points and or stationary points. You must determine the coordinates of the point of inflection. You must discuss the nature of stationary points, including local minimum, local maximum, and points of inflection. And lastly, you must be able to differentiate to maximize or minimize an equation. Okay, so grade 12s, basically those are the things that you need to know after we've covered this section. But as you can see here, there's quite a lot of things that we need to go through. So you will see that in this video, I will only be focusing on the introduction, and there are key concepts that we need to go through to understand the core of this topic, which is differential calculus. So in the next slide, I will go through the key concepts, and from there you'll be able to understand into more details what we'll be covering and what is that is required of you. So from now on, we're going to look at the key concepts. Okay, grade 12s, we are still under introduction, but we will now look at the key concept of differential calculus. These are what we call the building blocks, what this differential calculus chapter is made of. So in total, we've got 11 key concepts, or I will go through 11 key concepts. But for now, I'll only be giving you a brief description or a brief introduction of what you're going to expect. But going forward, I will create a video where I will be doing each key concept per that video or per that lesson. So here is just an introduction. So firstly, we will look at what we call functional notation. Then we will look at average gradient. Thirdly, limits. Number 4, we will look at differentiation from first principle. Then we will move to rules of differentiation. Number 6, equation of a tangent line. 7, polynomials. We will look at the remainder and factor theorems, which I believe are the new theorems that you've never seen before. 8, we will look at sketching of cubic graphs. 9, interpretation of graphs. 10, we will look at minima and maxima. Lastly, we will look at optimization, which is rates of change. So since we are still in introduction, I will just go in I will roughly go through each one of them so that I can give you an idea of what to expect in the next coming sessions. Okay, let me get my pen. Firstly, we will look at the first key concept, which is functional notation. In these grid 12s, we will look at your notation that you've already used in your functions. You remember the likes of f of x, g of x. Now we will look at notation as follows: h of x plus 1. We will analyze this type of notation to see what impact does this notation have on a given equation or graph. This is basically your horizontal change. If I go back to your functions and graphs, so we will look at how this actually impact your equations in calculus. Okay. Secondly, we will look at average gradient. We know that the gradient is changing y over change. In this case, it's going to be dy over dx. But here, if you check rituals, we are not talking only about the gradient, but we are looking at your average gradient. Why are we talking about average gradient? Because we'll be mostly analyzing gradients of cubic graphs, of curves. So we're getting an average, an approximation of a gradient. Because in a curve, if you've got a curve like this, there's no way in which you can get a gradient, because where you can get a true gradient, because this curve, it's not constant. It keeps on changing gradient. So it's not straight, basically. So we're looking at an average or approximation gradient. Okay. Thirdly, we will look at limits. This is going to be a new topic for you. Under limits, you will come across a notation like this: limit sh approaches 0. I don't want to dwell much into this, but you just need to know that under limits we'll be seeing this type of notation. Number 4, we will look at a very important key concept, a very important equation, which says f of x, or it can be g of x, it can be h of x, depending on the question, which is equals to the limit sh approaches 0 of f into x plus 1, f into x plus, what is it? I forgot now. X plus h, yes, minus f of x divided by h. So you will see that the concept of limits that we're going to cover in the third key concept, it is appearing again here. Also, your first concept of functional notation, where we look at your change here. Here we had x plus 1. Here we've got x plus h. It's basically the same thing. So we will look at how these two concepts, the concept of functional notation and the concept of limits, are used to come across or to come about or to actually develop this equation of first principle. Okay. Number 5, we will look at your rules of differentiation or your rules of derivatives. Here we will come across 5 rules, 5 very important rules, and these rules, they go hand in hand with the notation. But this notation, it's not the same notation that you are using under functional notation. These are what we call calculus notations. Grade 12s, this notation are very important. If you don't write the correct notations, you will get penalized and you will not get full marks on questions given. Okay, but don't worry, I'll explain into more details. Number 6, we'll look at the equation of a tangent line. Equation of a tangent line, we know equation of a tangent line, since a tangent, we know that it's going to be a straight line in the form y is equals to mx plus c. Okay, so I will come back, I will use the same graph that I draw the equation, the curve. So if you've got a curve and a tangent that is passing there, we will now say, okay, the gradient of the tangent at this point is the same as the gradient of the curve. So we will use this concept to actually draw equation of a tangent line. So in some question you'll be given the gradient of a curve, then you'll be asked to determine the equation of a tangent line. Sometimes you'll be given the, so it's vice versa, it's going to be around that concept of gradient, of derivatives of gradient of a tangent is equal to the gradient of a curve. So one way or the other you will have to use this equation. Okay, number 7, we will look at polynomials. Polynomials, we look at the two theorems, the two new theorems, remainder and factor theorems. I will also go through them each one by one in the next coming video. But what we need to know at this point is that we will use 3 methods under this section. We will look at what we call long division method, long division. Secondly, we will look at inspection method or method of inspection. Okay, and then we will move to graphs. So in this subtopic, or in this concept, we will sketch graphs. By now you can draw a straight line graph, you can draw a hyperbolic graph, you can draw a parabolic graph, you can draw your exponential graph. Now we look at cubic. Now a cubic graph will be something like this, where we will have one turning point there and one turning points there. So this is where we'll be sketching graphs. After sketching of these graphs, we will now analyze these graphs. Here we do a lot of analyzing and interpreting those graphs. So we will look at what we call your intercepts, because this graph now has 3 intercepts. You look at your intercept, you look at your point of inflection, you look at what you call your local maximum and your local minimum. We will see how we can actually determine or draw a parabolic graph when we're giving a cubic graph, and vice versa. So here is all about interpretation of these graphs. And then second from last, number 10, we will look at your minima and maxima. Grade 12, you would realize that in grade 12, you realize that in grade 12, you don't have this chapter, measurement. We don't do measurement, which is called measurement. But basically this measurement will fall under this section of calculus, under minima. So here we will be looking at your volume, your surface area, how we can actually maximize, these equations of measurement using calculus. So it's going to be interesting. So just hang in there, you'll see in the next coming videos what we are going to do here. Lastly, we will look at optimization. So grade 12 optimization here, those who are doing physical science will be mostly looking at physical science problems, your projectiles. So in a nutshell, grade 12 calculus is a combination of other subtopics, other chapters that you've covered in the previous grades, and they are just going to be combined into one. You will find your analytical geometries here, you will find that function and graphs are here, you will find that measurements is here, you will find that, different types of topics that you've covered before, we are going to use under this concept of calculus. So here, rates of change, you will also be focusing more onto the physical sciences. So yeah, that is all about the introduction of calculus. I just wanted you to have an idea of what you're going to come across in the next coming lessons and videos. So stay tuned for the next videos that I'll be uploading. I hope this video gave you an idea of what to expect. What I can say to you is that don't panic. I mean, all these things, they look scary, they are new. I'm talking about your inspection, I'm talking about optimization, I'm talking about your derivatives. But don't worry, I'll go through each one of them into more details so that you can be able to master this topic at the end of the day. So grade 12, stay tuned until we meet again. Continue practicing, and we'll meet again. Thank you.